Good morning, students. Now, the next part of the chapter, refraction of light. I've explained you in last lectures that what are the convex and concave lenses, and we know that what is the principal focus for the convex and concave lenses. And now, the next part of the refraction, that is the images formation by the convex and the concave lens. Now, first, we will prepare the image formation. We will prepare the image by using the convex lens. So first we should know the rules for obtaining image by using convex lens. Okay, this is a convex lens. If we draw this lens by using the compass, it will be really helpful to you to prepare the images. If you use a compass, then you can take the center uh, uh, of any length. You can take the radius of any length of the arc. The center which will you take as for making the arc is actually the length is 2f. The center which will you take as a for making the arc of this convex lens should be the 2f of this lens, and the same arc you can prepare from here like this, and it will also be 2f. The length should be equal of these 2f, and the midpoint of this one is f. So if you are using the compass, then it is only for when you use the compass. Otherwise, you can prepare the lens. The lens should be thin, and it and you should be sure that the distance of the optical center from the focus is always equal in both the sides, and the distance of this 2f is always double than this length. It means the focal length, if suppose focal length is 2 centimeter, then it should be also 2 centimeter. It means the distance of the 2f from the optical center will be 4 centimeter. So these distance should be equal for convex lens. Now the first rule is, when the light ray is coming parallel to the principal axis, we know that the light which is coming parallel to the principal axis always passes from the principal focus of the lens. So it will pass through the principal focus of the lens. This is the first rule. Okay, you can write, if the light ray is coming parallel to the principal axis of the convex lens, it passes through the focus after the refraction through the lens. This is the first rule. And what is the second rule about it? This is the lens. Again, the lens should be thin, and the distance, you can use the scale for preparing the images. This is f and this is 2f. I think you should prepare the image by using the compass, by using the scale. Now the second rule is, this is the optical center. If the light ray passes, I am representing it by using the symbol C. If the light is coming from this optical center, it will also, or it is always go straight without any deviation. This question should be in your mind, that why this light ray which is coming towards the optical center do not deviate. I think you should answer me, why this light ray do not deviate when passes through the optical center. So this is a question for you. Then why the light ray is not deviated? Okay, this is the second rule. When the light ray passes through the optical center, it go straight after refraction through the lens. Now the third rule. Third rule is the vice versa of the first rule. That is, we know that the light ray which is coming parallel to the principal axis always passes through the principal focus. And what happens if the light ray is coming from the principal focus, sorry. So the light ray which is coming from the principal focus is always go straight, is always go parallel to the principal axis. So these are the only three rules which we will use to prepare the images by using the convex lens. Now the images formation by the convex lens. First you have to write the heading, formation of image by using convex lens. Okay, now the first condition, when we place the object beyond 2f. This is a convex lens, it should be thin, and the distance of the principal focus should be always equal on both sides from the optical center, and this distance 2f should always be double than the focal length. Okay, this point should be always you should follow these points. Now the first one, if we placed now the first condition is if we place the object at beyond 2f, what will happen if we place the object beyond 2f? So this is the object, we can write it like AB. AB is the object. So first a light is coming parallel to the principal axis from the head of the object. I think you should prepare the images by using the scale, and this light ray will bend and it passes through the principal focus of the convex lens. Now the second ray, which is coming towards the optical center, passes straight without any deviation. If you use the scale, the figure will be really appropriate. So this is the image where the two light rays actually meet at the point. This is the image of the object, A dash and B dash. I am representing it by using the A dash and B dash. This is the image. And what is about the nature of the image? Now we know that the light rays actually meet at a point, or when the light rays actually meet at a point, the image is real. Okay, so first one, I am writing here the nature of the image. Nature of image formation. Nature of image. So the first one is, I am writing in the next page. First, it is a real image. Why it is real? Because the light is actually meeting at a point. Second one, it is inverted. You know, real image is always inverted. So we can say real, and second one is inverted. Inverted. And third one, this image is smaller than the object, so we can say the image is smaller than the object. And what is the position of the image? It is between f and 2f. So when we place the object beyond 2f, the image is always found between the f and 2f. So you can write it like smaller than the object, smaller than object, and the fourth one, in between f and 2f. Okay, so this is the first condition when we place the object in beyond 2f. And what will happen if we place the object at 2f? Object at 2f. Okay, so this is our convex lens, and this is the principal focus, and these are the this is a principal axis and this is a principal focus. F1 F2, you can write it like the F1 F2 and 2F1 and 2F2. So if we place the object at 2f, what will happen? The first light is coming parallel to the principal axis, always passes through the principal focus, and the second light ray, we can show it when it passes through the optical center, passes straight without any deviation. So what will happen? The image is always formed at 2f. It should be always formed at 2f. So what is the nature of the image formed? It is always real because the light rays are actually meeting at a point. So we can say it is a real, and inverted because real image is always inverted. And it is of the same size of the object. So we can say the same size of object. So image is of the same size of the object. And the next one is it is formed at 2f. Okay, so this is the second condition when we place the object at 2f. It always formed at 2f of the same side and real and inverted. Now the third condition, if we place the object between f and 2f, what will happen? This is the convex lens. Okay, f1, 2f1, f2 and 2f2. So we are placing the object in between f and 2f, not in at the midpoint. It means anywhere in between f and 2f. So first, the light which is coming parallel to the principal axis is passes through the principal focus, and the second one, which is passes from the optical center, always passes straight without any deviation. It always meet beyond 2f. So it means if we place the object between f and 2f, the image is always formed beyond 2f. Or if we place the object beyond 2f, image is always formed between the f and 2f. So we can write the nature of the image formed. First one, it is real because the light rays are actually meeting, and real image is always inverted. So real and inverted, and larger than the object. This image is larger than object. Okay. And the next one is, it is formed beyond 2f. Okay. uh, so I should write here where we are placing the object. So object is between f and 2f. Okay. Now the next condition, what will happen if we place the object at f? Object at f means at principal focus. This is a convex lens again, and this is a principal axis, principal focus. Okay. Now we are placing the object at f. The first right ray which is coming parallel to the principal axis passes through the principal focus, and the second right ray always passes through the optical center without any deviation. It passes without any deviation. So the light rays do not meet at any point, and we imagine that these light rays will meet at infinity. So we will say the image is formed at we imagine that the light rays is meeting at the infinity. So we can say this is a real image, and real image is always inverted. So real, inverted, and highly magnified. If they will meet at a larger distance, it means the image will form highly magnified. So we can say highly magnified and at infinity. So this is the nature of image formed when object is placed at f. And now the next one, if we place the object in between optical center and the principal focus. This is a very special condition for the convex lens. Object between principal focus and optical center. So this is a convex lens, principal focus, and this is the object. We should always write it like AB. A light ray which is coming parallel to the principal axis passes through the principal focus, and light ray which is coming towards the optical center is always passes straight. Now these light rays do not meet at a point on this side. It appears to meet at the point on this side, like this one. So they appear to meet at this point. So they are not actually meeting. The light rays are not actually meeting. It appear to be meet here. So when we show the light ray are actually not meeting, they are appearing to be meet, it means it should be represented by using the dotted line. So you should use the dotted line for representing it. Now this is the image. This is only the single condition in which the image is formed on the same side of the object, and the light rays are not actually meeting. It means when the light rays are not actually meeting, they form the virtual image. So this image is virtual. Only the one condition where the convex lens can form the virtual image. When we place the object in between the f and the optical center. So the image is virtual, and virtual image is always erect. Like in mirror, when you see your images in mirror, you always see your erect image, है ना, सीधा दिखाई देता है. तो erect, virtual, erect, and larger than the object. So that's why we use this lens as a magnifying lens, larger than object. So this is only the special condition when we place the object in between f and c. So always it form the magnified and virtual and erect images. And the next one, when we place the object at infinity, the object at infinity. So what type of image will be formed when we place the object at infinity? The light which is coming from the infinity is always parallel to each other because they are traveling a long distance. F1 to F1, F2 into F2. So we can represent it like these are the two light rays which is coming from the infinity to the towards the convex lens. So when the light ray is coming from the infinity, it means they are parallel to each other. They will meet at principal focus. So when we saw the image of the object which is placed at infinity, it always formed at principal focus. And since the light rays are actually meeting at the point, it means the image is real. Real. And what is about the size of the image? The infinity, if we saw the object which is at infinity, it means the object is really so large, but the image is formed is so diminished. So we can say highly diminished image is formed. Highly diminished. Highly diminished. And real, highly diminished. And real image is always inverted, so it will be inverted image. Inverted. And what is the position? The position is at F. So these are the images formation by using the convex lens. You should always remember these all type of images which is formed by the convex lens, because it will be helpful for you for do the numericals which are based on the convex lens. Okay, bye.